Namaskar. Uh, in this audio, typically we will discuss the use of XOR gate as parity generator and parity checker. Uh, as a background, I have given you a homework to prepare a truth table for 4 input XOR gate and 5 input XOR gate. Also, I have shared with you the image or a photo of the writing material. I will display it at the end of this video too. Now, what is the parity bit? Typically, in case of the communication, suppose we will have to send some data from one end to other in the form of either parallel communication, that means with help of 4 wires, 8 wires, etc., or in the form of serial communication, that is one by one. To assure the validity of the data at the receiving end, we will have to generate a bit which is known as parity bit. The purpose of this bit is to ensure that the data received at receiver is valid, it is error free data. Now, what is the meaning of error free and what are the limitations of this type of parity generator and parity checker? See, if I send 4-bit data and if during the communication if there is change in one bit, it changes from 0 to 1 or from 1 to 0, then the data received at receiving end is not correct data, it is with an error. To get whether it is correct or not, we can use a parity bit. Now, how it is used? For that, we will go through the image and then we will have some discussion. See, already I have shared this image with you. Now, you will observe that here it is the 4-bit XOR gate, and this is the truth table for 4-bit XOR gate. You will observe that the output is 1 if odd number of inputs are 1, and therefore including this column you will observe that it is total number of ones in the data, that is these 4 bits along with the output, and this output is known as a parity output or parity bit. Now, interesting thing is that along with the 4-bit data, if I include the parity bit, that is output, then number of ones is always even, correct, is always even. And therefore, what the parity generator will do, along with the 4-bit data, this 4-bit data, the output of XOR gate is transmitted. Therefore, the transmission is of these 5 bits from D3, D2, D1, D0. These are the data bits and the parity output. You will observe that in these 5 bits, number of ones is always even, correct? Number of ones is always even. Now, this group of 5 bit is transmitted from the transmitting end and it will be received as a data at receiving end. Therefore, now we will have to check whether the data received, that is D3, D2, D1, D0, is valid or is there any modification, is there any error in the data received. For that, we will have to think about this 5-bit XOR gate. Now, what happens in this case? You will observe the truth table you have already prepared as a homework, but you will observe that if the number of ones in D3 to D0 and parity, if it is even, then the output will be 0, and it indicates that the 0 output indicates that the data received is the proper data. Now, why proper? See, you will observe that if for any data input the parity generated such that always the number of ones in this 5-bit is even, and if it is even, then you will observe that if it is even, then the output will be 0, and the 0 indicates that the data received is correct data, there is no error, and you can use this data D3 to D0 as the data as it is. But if the total number of ones is odd in this, that means there is a mistake. Either there is modification in parity bit or there is modification in data, and therefore the number of ones is odd, and the output of this 5 bit XOR gate will be 1, which indicates that there is error. And therefore, as a conclusion, we can say that if z is equal to 0, it indicates that received data, that is D3 to D0, is without error, and if z is equal to 1, then it indicates that the received data D3 to D0 is with error. Now, this circuit is referred as the parity generator. Therefore, it generates the parity bit such that the data along with the parity bit includes even number of ones, and this circuit can be treated as the parity checker. It checks the parity. If along with the parity bit and data number of ones is even, then it will indicate that the data received is proper data, it is valid data, otherwise it will give you the signal of error. Now this is the parity generator and this is the parity checker. This is the truth table for parity generator. It indicates that the number of ones in the data along with the parity bit is always even, and therefore it is referred as even parity. If I use instead of XOR gate X NOR gate, that means complement, then it will be the odd parity bit. Same thing is here. It will check the odd parity. Thank you.